This video illustrates the process or processes used to fabricate the bipolar electrochemical chips used for heavy metals detection in water. So start by prepping the jig molds by adding tape to each of the protruding portions of the jig. You can line it up on a piece of lab tape and very carefully apply them so they fit exactly on each part of the jig. Wrap them around, cinch them down very tightly while you're wearing gloves. You're going to do this for each of the jigs, each of these little inserts that are going to fit into the overall mold. That's one completed jig insert there. Now you're going to need to clean out the actual mold. This is where you're going to pour the PDMS later. So go through and take any of the old cured plastic out of there with tweezers or razor blade. Go in there with a wooden dowel and really clean it up. You need to make sure it's absolutely clean so you get good adhesion. You can also use a kimwipe with solvent like isopropanol or methanol. Scrub it down, make sure the layer is completely flat on the top and bottom so that it fits well in the assembly later. Okay, now we need to grease the mold with vacuum grease. So use another wooden dowel and you're going to go on the inside of all the molds. You're going to line every little bit of it with some vacuum grease. The point of this is when the PDMS cures as a polymer, this will prevent it from adhering too much to the mold. If you skip this step or you do it loosely and you don't cover every single aspect, then as you try to remove your molds from the chip, they're just going to stick to the plastic and they're going to rip right off the base of the FTO glass. So this is a pretty crucial step. So be thorough here, make sure you completely cover all the sides. You don't want big globs or excess there. You just want to make sure it's completely covered so there's a very thin layer of that vacuum grease over every single one of those interior molds. Go ahead and wipe off the grease off the top so you don't have anything on the top of the mold. Okay, now for assembly, take the base plate, then the rubber gasket, make sure the bolt holes all align perfectly. Take the series of bolts, thread them through the back or the bottom of the base plate there, back through the rubber gasket. Insert all of the bolts like this. And then once all the bolts are inserted, you're going to carefully hold the bolts with one hand so they don't fall back out, and then lay it flat, just like that. Clean off anything that is stuck to the gasket, otherwise it will crack the glass if there's any little chips or pieces of anything that are stuck to the rubber gasket. Now you need to take your FTO glass. This is pre-patterned on the laser cutter, so following a different protocol. So you're going to pre-pattern that and you're going to drill those holes on a drill press. Then you're going to take your greased mold plate and drop that on top over the bolt holes. And then you are going to take the inserts which you taped previously. The tape just helps with the adhesion a little bit more. Now you're going to grease both the sides and the bottoms pretty thoroughly using the same wooden dowel and vacuum grease you did before. Do that for both sides and in between all of the little nooks and crannies of these. Otherwise, they're not going to be able to be removed when you cure this. So add a whole bunch there. Do that for all of your inserts, and then you're going to drop those into the mold for each of these. Each one of these is going to form a chip later. The more liberal you are with the grease now, the less work it will be to remove your chips later. So drop those down into the mold plate. Do that for each one of those inserts. Now for the top plate, make sure you line it up right. For the bolt holes, drop that over top. Now add the nuts and finger tighten each of the nuts till they're all completely placed on top of the mold to secure the mold assembly. So this is the assembled mold from the side. Make sure everything's nice and finger tight there so that it's compressing the gasket underneath, but it's not too much. If it's more than finger tight, it'll crack the glass. Sometimes you may need to hold the bolt from the other side with your finger on the underneath while you're finger tightening so they don't rotate in place. All right, now we need to prep the PDMS. So there's two parts to the PDMS. There's the large bottle and the small bottle. The large bottle is the monomer. You're going to start with a 150 ml beaker and slowly pour that in until you have roughly 25 grams. We're mixing this in a 10-to-1 format, so 10 parts to 1 part by mass, so 25 grams of the monomer, and then to that we will add roughly 2.5 grams of the catalyst, which is the small bottle. Try to get close to the 10-to-1. Doesn't have to be completely exact, but roughly. You can use the analytical balance, or probably even better would be to use the top loader balance in this case. Okay, now we need to degass that solution. So start by mixing it up thoroughly with a wooden beaker or with a wooden dowel. Mix it up thoroughly. You're going to drop it into this vessel, which is attached to a small vacuum pump, and you are going to pump on this for at least 30 minutes, which will pull as much of the air out of the PDMS solution as possible. Okay, so now we need to actually inject our PDMS solution into the mold so it can cure. So you're going to do this with a syringe. So get a new syringe with a new needle with a luer lock, attach that, pull the plunger out, and very slowly and carefully start to pull that PDMS solution or draw it up into there. If you pull too fast, you will insert air, so be really careful here. You can also pour if that's easier for you, whatever method is easier. It's inevitable you're going to get some air in there, but you can tap the syringe to try to get the air to float to the top of the barrel so that it becomes inconsequential when you're dispensing into the mold. You can see the air bubbles there. The larger bubbles are the ones that are mostly problematic here. Okay, so in each of the holes in the mold, you're then going to dispense until you see liquid PDMS coming out from the other hole on that particular chip. You're going to continue to dispense in all of the chips until there's excess PDMS, as you see here, from each one of these sided chips. Okay, then you throw it in the oven as per the SOP. Then you're going to disassemble the mold. It can be helpful. First pull the nuts, pull the top plate, and then you can get a brand new razor blade and go and sort of slice up the edges of each of the inserts just to relieve any PDMS that's bound to the PMMA mold template there. Do that for each of those, and then very slowly sort of push down on the inserts while you pull up on the mold. And as you do so, you can pull the whole mold plate up and off, and what you should be left with, if you greased it well, are a bunch of freestanding inserts on top of your PDMS wells that are stuck or adhered very well to your FTO plate where your electrodes have been patterned. So push the bolts out of the back, and then you're going to peel off the base plate and the gasket, so what you're left with is the freestanding piece of FTO glass along with the chips. Okay. We could use it as is, or we could pull the inserts out, or we could cut this in half. There's reasons why you may want to cut this in half just for ease in terms of experiment, but it's not always necessary. To cut them in half, you're going to use the glass saw. So the glass saw, you can turn on the pump, the water pump, which is going to give you some cutting fluid. Turn on the glass saw, and then you're going to slowly cut right in between your inserts, being careful not to cut your inserts and being careful not to cut through any of your devices or any of your chips. This will liberate the two halves of your FTO sheet, and so you'll be left with a sheet of 5 devices and another sheet of 5 devices. The depth of the actual saw can't cut through the entire width of the FTO sheet, so you'll have to flip it around and cut it from the other side. So there are your 2 sheets. Now we need to pull the inserts out of each of those. So again, using a nice fresh razor blade, go in there and sort of give yourself a little bit of clearance by cutting along the edge of the insert, being careful not to cut through your entire PDMS so that it leaks later. So you do this and then take 2 sides of a forceps and clamp on and sort of pry it and wiggle it loose. So here it's a little delicate because you want to remove your insert, but you don't want to pull so hard that you pull the PDMS completely off the FTO. If you do that, the device will leak and that will be a failed device. You won't be able to use that. So sort of wiggle it out. You'll see that the tape actually helps that, and so does the grease. This is why all the taping and greasing was done at the beginning. So there is a picture of sort of a rough looking device. You want to go through there, remove all the inserts there. Take care and go slow with this process because you've already put in so much work here. You don't want to lose the functionality of any one of these chips right at the last moment. You're going to reuse those inserts again, so you're going to want to peel the tape off, and then I like to take them all and throw them in an isopropanol bath and put them in a sonicator for a period of time. Now you can go in with scissors and just remove any of the excess PDMS that squeezed through the mold that you don't need. Okay, now we need to clean these things really, really thoroughly. And so what you're seeing here is just starting at the edges, using a wooden dowel and just scraping away any thin layer of PDMS that is covering up that little bit of FTO that sticks out from the underside of the PDMS. That's where we're going to clip the alligator clips to run our devices. And so any little thin layer of PDMS there is going to prevent electrical contact. So you can go through there and scrape. Wooden dowel is nice here because if you use metal, you can actually score the FTO, which will break contact. And so you can go through there, peel that up with a wooden dowel and some tweezers, and make sure you've completely removed it so you get nice electrical contact later or making contact with the device. Now go in there with a little bit of methanol or isopropanol on a kimwipe and really polish those down after you've removed the bulk of the PDMS using an abrasive or a tweezer. Okay. So once you get the edges all cleaned up, those are where you're making contact to your driving electrodes, now you need to clean the inside of the wells. And this is arguably the most crucial step of the entire fabrication. Because you use so much vacuum grease before, vacuum grease is non-conductive and inert. And so if there's a little bit left in the bottom of any of your PDMS wells or reservoirs there, then it will impede contact between the solution and your bipolar electrode. So it's really crucial here. One mechanism to do this is to take a wooden dowel and to take a little bit of a kimwipe, dip it in methanol, and then use that to rub it around in the base. I like to break the dowel just to effect a sharper point. You'll see that later in the video. So you really want to scrub this thoroughly. If there's any bit of grease there, you won't make contact because the grease will block the water from actually making contact to the FTO and your device won't work. So this is a crucial step where you're going to want to spend a little bit more time again to get this nice and cleaned up. You can see the fracturing of the stick here in a second. Oh, maybe not. Scrubbing a little bit along the edges again, just to clean up the contact pads to the driving electrodes. That's where we'll clip the alligator clips. So you've got this nice clean chip. So there you see breaking so that you get a sharp interior piece of the dowel. That'll allow you to really get in along the edges of the PDMS and those wells and clean it up. You can see from these chips there's quite a bit of bubbles here. It might have been a good idea to degas this for a little bit longer, or to maybe pour the PDMS solution into the syringe rather than drawing it up. Okay, so the last step is to actually make conductive contact to the FTO. This isn't totally necessary, but it helps make more consistent contact. So these bottles are colloidal silver, so the silver settles out over time. So anytime you use it, you really want to mix it up for at least a minute. If there's not enough solvent in there, you can add xylenes to that and mix it up. You'll add that to each of the pads, and bam, you've got a nice completed chip. You'll do this for all your chips, and then you're done.